Friday, March 27th, Math. We are starting a new chapter today. We finished up our geometry chapter, and I hope you did pretty well with the area and perimeter and all of that, and you did your review well yesterday. Now we're moving on to fractions. Let me say something. If you're still confused at the end of my video and you're still having problems with something, please make use of YouTube during this time. If you have access to it, get on there and just look up multiplying a whole number and a fraction, or look up what you're trying to struggle with. And there are lots of teachers, there's lots of people who make videos to talk about these things. So please, make use of that. If you're still struggling, if whatever I said didn't help you very much, use that. You can also play me again. Say, I didn't quite get that. Don't give up. Be like Brian in Hatchet, okay? He didn't get it the first time, so he kept going back. He kept going back. He kept going back. That's your job. Right now, your survival is getting through your schoolwork, and that is your job. And you're going to find a new sense of pride just like he did if you can get through this. If you can get through, not just get through it, but get through it successfully. If you can look back and say, wow, look what I did. I did that on my own. I can do this. You're going to have a new sense of pride just like he did. So if you struggle with it, play the video again. Okay? Don't give it up and throw it away or crumple it up and say, I can't do this. Keep working. It's your job to figure it out. It's my job to help you as much as I can. You can also call me. You have my telephone number. Call me and say, Mrs. Barnett, I'm really stuck on this, okay? And I will help you. Now today, so we are in chapter 12, and this is page 267. So at the top, it says multiply a whole number and a fraction. Multiply a whole number and a fraction, okay? Now I like these because I think we can break this down enough to really understand this. So if multiplying is just repeated addition, right? And it is. We know how to add fractions, especially if they have the same denominator. And if it's repeated addition, that means it has to be the same number. So it's going to be a same denominator. So that's easy. I know that if I add 3/8 plus 3/8 plus 3/8 plus 3/8, I'm going to get what? 12/8. Now, you know already I've explained to you that this is the way I'm going to do computers, or I'm going to do fractions on the computer, the little slanty line. So, but that's the same as the fraction on your page where it has the horizontal line, okay? All right, now, so we've got 12/8. Look at what happened. What did we do? Is there a simpler way to say this? So this problem really is 4 times 3/8, right? So look at my answer. What did I wind up with? I wound up with 12/8. Let's look at that again. So what happened to the fraction? First of all, what's the denominator? 8. Did the denominator stay the same? Yes, it did. So and look at 4 and 3. They got multiplied and the denominator just moved over. Another way to look at it is, if you have a whole number in fractions, another way to write it, instead of writing just 4, in fractions I write that 4 out of 1, right? One whole piece, and I've got 4 one whole pieces. So another way to write that is 4/1. Now let's take that. Let's say that I have 4/1 times 3/8. Now look at that. It's a little bit harder to see than if we were writing it in the book. But 4/1 times 3/8. All I'm doing, I am multiplying the top numbers. So do you see? I made the whole number into a fraction, and then I multiplied the top numbers and I brought over the denominator. Simple. So let's put this down into steps so that we know exactly what we're doing. Since the book is just going to show you the whole number, we're going to multiply the whole number by the numerator. Let's use proper terms here. By the numerator. Then bring over the denominator. Okay, so we're going to multiply the whole number times the numerator only. Then we're going to keep the denominator the same. Then we need to always remember when we're dealing with fractions, look to see if we can reduce. Okay, that means divide the top and bottom number by the same number. So up here, our answer was 12/8. 12 over 8. Can that be reduced? Yes, it can. I can divide top and bottom by 4. So if I divide the numerator and the denominator by 4, I get 3 over 2. Whoops. 3 over 2. Now, I'm still not finished because I need to turn improper fractions into mixed numbers by dividing the bottom into the top. Okay, so I can't leave it as 3 over 2. So 2 goes into 3 one time with a remainder of 1, and I'm going to put that over 2. So my answer is 1 1/2. 12/8. I can reduce it to 3 over 2, and then it gets turned into 1 1/2. Are you following me? Okay, let's do a few of these together. So look on your page. Look at number 1. Number 1 says 3 times 2/3. 3 times 2/3. So what was our steps? We're going to multiply the whole number times the numerator. 3 times 2 is 6. Then we're going to bring over the denominator, which is 3. So we have 6 over 3. Now we're going to turn it into either a whole number or a mixed number. So 3 divided by 6 is, I said it backwards. 6 divided by 3 is 2. There's your answer. Number 2. 4 times 4/5. Okay, what's our steps? Multiply the whole number times the numerator. 4 times 4 is 16. Next, we're going to bring over the denominator, which is 5. Then we are going to turn it into a mixed number by dividing. 5 goes into 16 3 times with a remainder of 1. So that's going to be 3 1/5. 3. 5 times 1/4. Multiply whole number times numerator. 5 times 1 is 5. Bring over the denominator. So we bring over the 4. Turn it into a mixed number. 4 divided into 5 goes once with a remainder of 1/4. Number 4. 3 times 5/6. Multiply numerator times whole number. 3 times 5 is 15. Bring over the denominator, which is 6. Make a mixed number. 6 goes into 15. 2 times with a remainder of 3. 2 and 3, 6. Uh-oh, what do we need to do now? Reduce. That should be 2 and 1/2. Good, I knew you'd catch it. 5. 4 times 3/4. Multiply whole number times the numerator. 4 times 3 is 12. Bring over that denominator. 4. 12 divided by 4 is 3. 6. 5 times 1/2. Multiply whole number times numerator. 5 times 1 is 5. Bring over the denominator, which is 2. Excuse me. Divide 5 by 2. So 2 goes into 5 2 times with 1 left over. 2 and 1/2. Okay, now you have some input and output tables that are doing the same things that we just did. See the little dot at the top of the chart? It says dot. It has the dot. We talked about the dot meaning multiply. So you're going to multiply that number times all of the ones down here in the chart, which is exactly what we were doing up here. Make sure that you turn them into lowest terms when you're finished. Now look at the back. A lot of the same. Practice, 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 practice. 10 through 15 says write an addition equation to solve. You can if that helps you. You do not have to because we've talked about the process. You can use the process. I want you to practice doing the most efficient way, not just an old way. And the most efficient way is learning how to multiply it. So all of those 10 through 27 is just practice over what we just did. Then your word problems. So let's make sure the word problems are talking about multiplying also. So look at 28 with me. Now I'm on the back. Allison made 4 kites. She used 5/8 of a yard of ribbon for the tail of each kite. How many yards of ribbon did she use? So yes, that's going to be multiplying. 4 kites times 5/8 each time. Okay, I'm not going to work that out for you because we just did several and you know how to do it now. Walk through your steps. Number 29. Michael spent 3/4 of an hour working on his kite each day. It took him 8 days to finish the kite. How much time did he spend on the kite? So if it's 3/4, we're going to do 8 times 3/4, and then that'll tell us how many whole hours he wound up spending. Kara made 2 kites. She used 1/2 of a yard of ribbon for the tail of a red kite and 7/8 of a yard for the tail of her blue kite. How much more ribbon did she use for the tail of her blue kite? Now is that multiplication? No. How much more ribbon did she use? Okay, so this is subtraction, right? So which one is bigger? The blue kite. So 7/8 minus 1/2. Now you know you need to change those denominators. So it's really going to be 7/8 minus, how do I change half to have a denominator of 8? What's half of 8? 4/8. 7/8 minus 4/8. Now look at the last one. Carlos spent 1/2 of an hour working on his kite each day. It took him 9 days to finish his kite. How much time did he spend on the kite? Okay, so same thing we're going to do with Michael, except it's going to be 9 times 1/2. And then there's a second part to the question. Don't miss it. Did he spend more or less time building his kite than Michael? Okay, more or less time than Michael. So then answer that. Okay, I think you got it. I have all confidence that this is not going to be any problem for you. And if it is, I have confidence that you're going to stick with it and keep practicing and get it down. Down below, in the comments. Just tell me you got it and you're moving on.